These are the frequently asked questions for Algebra 2 for Section 6.5, Day 2, starting with number 29. And we have the square root of 11x plus 3 minus 2x equals 0. And as we've been talking about in class, you have to isolate the radical. So what I have to do is I have to move this 2x over to the other side, just using addition. So square root of 11x plus 3 equals 2x. Now, to get rid of a square root, you need to square both sides. This will give me 11x plus 3. And on the other side, I will get 4x squared. And that's because we have to square everything that's on that side. Now, I notice I'm going to have a squared term. And again, easiest way to solve those would be to factor. So I'm going to go ahead and subtract 11x from both sides and subtract 3. And that will give me 0 equals 4x squared minus 11x minus 3. I'm going to try and get the smartboard to let me move this down. It's been having some issues with that. So now what I'm going to try and do is factor it, and I notice that the first term up here is a perfect square, but the last term is not. There's no way that I can factor out a common monomial factor, so what I have to do is I need to think of all the combinations of numbers in the front that would give me 4, and those are it. And in the back, the combinations of numbers that would multiply to negative 3. And then find the set of numbers where outside times outside plus inside times inside will add to negative 11. With this combination of numbers, I'm looking for a negative 12 and a 1. So I notice here and here I would have negative 12 for outside times outside. And here for inside times inside, I'd have a positive 1, and that will do it. So what I want to do is remember that these numbers came from first times first, so those are going to go in the first positions. I'm just going to put x for 1x. And then these two came from last times last. So plus 1 and a minus 3. So 4x plus 1 could equal 0, and that means that x could be negative 1/4. And then, write that so it's readable, x minus 3 could equal 0, so that means x could equal 3. And this is a situation, again, where we need to check those answers. I'm not going to bore you with that. I am going to tell you that one of those does not work. So you can go ahead and check those, and then you can throw out the one that does not work. And that, again, is going to happen when we raise to a power in order to solve. It's just one of the effects that happens. Number 31 has the square root of 3x plus 13 minus 5 equals x. Pretty obviously, to isolate the radical, I have to add the 5 to both sides. And if I'm going to get rid of that square root, I'm going to have to square both sides. So that will give me 3x plus 13. But over on the right-hand side, I need to remember that I cannot, absolutely cannot distribute that 2. There's addition taking place in those parentheses. The only time that we can distribute a power is when we see pure multiplication or division. And then you'd go ahead and do FOIL or remember the pattern. And realize that, again, we need to get all of this over on one side because it's going to be a quadratic. So I have to subtract 3x from both sides. That'll give me a 7x. And then subtract a 13 from both sides. That will leave me with 12. And I'll scoot this up. And this one, not such a complicated factoring problem this time, because we have a 1x squared in the front, and x times x pretty obviously is going to give us x squared. Now I just need two numbers that multiply to 12 and add to 7, and that's going to be 3 and 4. So my two solutions are negative 3 and negative 4. And I will leave that for you to check the answers, and I will tell you nothing more because I don't want to give it away. So go ahead and check those two answers for 31. Then number 35, we have the square root of 3x equals the square root of x plus 6. And every year people want to overthink this problem. You already have the radical isolated, it just happens there's one on each side. So just square both sides. 3x equals x plus 6. Subtract x from both sides. 2x equals 6. Divide by 2. And x equals 3. So again, you're going to want to check that answer and make certain that that is going to work. Number 39 is an interesting problem. So let me erase this one and start working on number 39. We have x plus 5 to the 1/2 minus 5 minus 2x to the 1/4 equals 0. Now we know we're supposed to isolate the radical, and that means we have to get one of these on each side. So I am going to add this entire mess right here to both sides of the equation, and that will give me x plus 5 to the 1/2 equals 5 minus 2x to the 1/4. So now I'm thinking, okay, I need to take the reciprocal of the power in order to get rid of it, but which one? So I have a 1/2, which I'd like to use 2 for and be done with it. Use a 2 as my power and that'll be gone. But if I use a 2 on the right-hand side, I'm not going to eliminate my radical, which is the 4th root. So I have to raise both sides of this equation to the 4th power, to the higher of the two powers in order to get rid of it. Over here, I'm going to have x plus 5 squared, but on the right-hand side, I'll just have that 5 minus 2x. Now, already twice we've had to do x plus 5 to the x plus 5 the quantity squared, so hopefully you have that memorized or it won't take you too long to get that. And then we'll move everything over to one side, so we will add 2x to both sides, making it 12x, and we will subtract 5, and then we'll factor. So we need two numbers that multiply to 20 and add to 12, and that's going to be a 2 and a 10. So our two solutions are -2 and -10. But again, for number 39, just like for any of these, you need to check those solutions. I will tell you that only one of them works. So make sure that you check those solutions. Then, number 41 is another really interesting problem here. The square root of 5 minus x minus the square root of x equals 1. Well, I need one radical on each side of this thing, so again, I'm going to move one over, and I certainly would choose adding over subtracting any day. So that will give me the square root of x plus 1. Now again, this is going to seem a little weird, but we have square roots, which means we need to square both sides. On the left-hand side, we'll get 5 minus x. On the right-hand side, things are not so wonderful in radical land. So, let's see what we get. Well, first times first is the square root of x times the square root of x, and that's going to be the square root of x squared, which is just x, so that was good news. But outside times outside is 1 square root of x, and inside times inside is 1 square root of x, so that's going to be plus 2 square roots of x. Now, why do I say that's unfortunate? Because we're going to have to square this again in order to get rid of that. And then last times last is just 1. Now, what we have to do is isolate the radical. That means we're going to have to subtract the x and the 1 from both sides just to get that radical alone again. And at this point, we would divide by 2 because we can. It's going to work out really nice. and we will square both sides to get rid of the radical. So this will be 4 minus 4x plus x squared equals x. Move the x over, and I'm also going to put this in standard form. So now what I need to do is factor. I need two numbers that multiply to positive 4 but add to negative 5, and that's going to be negative 4 and negative 1. So my solutions are 4 and 1. Again, I'll leave it to you to check and make sure that both of those are going to work. However, I'll tell you only one of them does, so make sure that you check those. Number 48 says we can find the area A of a square whose side is s units with the formula A equals s squared. What's the best estimate for the side of a square that has an area of 32? All right, well that would mean I need to take the square root of both sides. So we'd grab a calculator, or we could sit and think about it for a little while, The square root of 32, well, that's bigger than 5. 5 squared is 25, but it's not as high as 6 because 6 squared is 36. So I don't even need a calculator because the only thing it could possibly be is 5.7 meters. Obviously, if this is on the ACTs or something, you're going to use your calculator just to make sure that you have the best estimate with that one, but in this case, we can just reason our way there. Number 53 has the square root of x squared plus 3 equals x plus 1. And the radical is already isolated, so I'm going to go ahead and square both sides. And I get x squared plus 3, and on the other side I have an x plus 1 and an x plus 1. So x squared plus 3 equals x squared plus 2x plus 1. And this one, I look at it and realize I'm not going to have to factor to solve this because as I move everything over to get my 0, the x squareds are going to cancel each other out. So I can subtract 1 from both sides and then divide by 2. And I get x equals 1. No guarantee that's going to work. Make sure that you check number 53 to see whether or not that one works or not. Then, number 54. That back up there where it's supposed to be. There we go. So 54, 2x plus 3 raised to the 3/4 minus 3 equals 5. I have to isolate the radical, which in this case is the parentheses. That means I'm going to need to add the 3 to both sides. Then I'd go ahead and raise that to the reciprocal power. And that will give me 2x plus 3 equals, well, this would be the cube root of 8 to the 4th power, and the cube root of 8 is 2. 2 to the 4th is 16. And then I'll subtract 3 from both sides and divide by 2. And I get x equals 13 halves. And unfortunately, I think the book puts that into a decimal. But you know what, when you check it, it's much easier to check it as a fraction because 2 times 13 halves is 13. So when you're checking it, just leave it as a fraction as you go through there. Then number 59 says a student says that 4 and 1 are solutions of the problem shown. So what I'm going to do is I'm just going to write down the problem and then totally ignore their work. Because once you look at somebody else's work, you convince yourself that it's correct. So I need to subtract 2 from both sides to isolate the radical, and then I need to square both sides to get rid of the radical. So that will give me x, and then x minus 2 times x minus 2, which is going to be x squared minus 4x plus 4. And then I'd have to move that x over by subtracting. And this looks a lot like a factoring problem we just did in this assignment. So no common monomial factor. I noticed that I need them to multiply to positive 4 and add to negative 5, so that'll be negative 4 and negative 1. And our two solutions would be 4 and 1. So now I have to go back and figure out how did they mess up in all of this. So we have the exact same thing that they do. And I realize, well, it must not have been the math that they did wrong. They must not have checked their answers. So for number 59, what we have to do is we have to plug those in and make sure that they're both going to work. I mean, that's the only thing they could possibly have done wrong because the rest of the math is good. So describe and correct the student's error this time is going to mean checking. So the square root of 4 plus 2, does that equal 4? Well, that's 2 plus 2, and it equals 4. So 4 is just fine. Now we'll try our solution of 1. The square root of 1 plus 2, does that equal 1? No way. We've got 1 plus 2 equals 1. No, it doesn't. So what they did wrong was they didn't check their answers because 1 is extraneous. And that needs to be what we describe. They forgot to check for extraneous solutions. X equals 1 does not work. So there's our description of their error. I'm going to go ahead and erase this and talk to you about problem number 60. The velocity of an object dropped from a tall building is given by the formula v equals the square root of 64d, where d is the distance the object has dropped, and we are supposed to solve this formula for d. Pardon me. So the radical is already isolated in this. What we need to do is we need to square both sides to get rid of the square root. So v squared will equal 64d. Now if we want d all by itself, we'll have to divide by 64. So v squared over 64 equals d. And that one is done. 63 says, a teacher asks students why it's necessary to check for extraneous roots when squaring both sides of the equation. Which of the following answers is the best? Is that answer complete? And explain. So what we want to do is think, okay, which one of these is going to work best here? A says because the squared equation can have negative roots. Well, a squared equation, square roots do. B, because squaring is multiplication and any multiplication is a potential source of extraneous roots. No. Multiplication of any kind, no, that does not give you extraneous solutions. It's all about the power. C says because when you square both sides of the equation, A equals B, you add to the solution set the roots of the equation A equals negative B. Now that makes more sense because we're talking about the fact that when we have to raise something to a fraction power where there's an even number, that's when we have those absolute value pieces that have to take place. But let's read D and see, is there a better answer? Because any operation with an equation may result in extraneous roots. No, that's not true. So our best answer here is going to be answer C. Right there. And the book actually did not have you do the rest of this. We're going to treat this like it's an ACT problem, which in that case would mean it's just multiple choice. So when it says which of the answers is the best, we're just going to stop there. Is this answer complete? We talked about this in class about how when we're raising it to the even powers with our fractions, what we're really doing is if the even number is in our denominator, we're taking the square root, the fourth root, the sixth root. So we're really taking an even root, and that would be a full explanation of what's going on. But like I said, if you just put C down, I'm okay with that. So that will be it for the FAQs for this section.